Welcome to the Deep Dive. Today we're tackling a topic that's both incredibly complex and utterly fascinating. The Meta Quotient Information Principle, or MQIP. Now, MQIP is a theory that's, well, it's a lot. It suggests that reality isn't just a random jumble of stuff, but a carefully structured hierarchy built on information. Think layers, think compression, think Reality.jpg. Prepare to have your assumptions challenged. Prepare for Reality.jpg.
Warning: this podcast is extremely meta and challenges to push your brain to its limits. Grab a snack and watch this after a sleep if you have to. If you're ready, enjoy the show.
All right, get ready, because today we're diving headfirst into something really mind-bending.
Yeah.
MQIP.
MQIP.
The Meta Quotient Information Principle.
It's a mouthful.
Yeah, it's a theory that suggests reality might be a lot more structured than we think. Kind of like a giant computer program.
Right.
Running on a hidden code.
And that's that code.
Yeah.
According to MQIP, is built on this hierarchy of information processing.
Okay.
It proposes that reality isn't just one big messy thing.
Right.
But rather it's organized into distinct layers.
Layers.
Yeah.
So it's not just atoms and galaxies all mixed up together.
Not quite.
Oh.
Think of it more like a cake.
Okay.
Each layer is distinct, but it's built upon the one below it.
Right.
At the very bottom, you have the most fundamental stuff. Raw quantum information.
So that's the base of our reality cake, so to speak.
Exactly.
Interesting.
It's the foundation.
So what kind of layers come next? I mean,
Right.
does it go straight from quantum fuzziness to planets and people?
Well, not exactly.
Okay.
As we go up the layers, things get more complex.
Right.
We move from space-time to particles,
Oh.
then biological life,
Okay.
brains,
Okay.
and perhaps even consciousness itself.
Oh.
Each layer represents a higher level of organization built upon the information from the level below.
Okay, I'm starting to get a picture here.
Yeah.
But how does reality decide what information to keep as it moves from one layer to the next?
Right.
It sounds like a cosmic game of Jenga.
Yeah.
Pull out the wrong piece and the whole thing collapses.
That's where the idea of this quotient space comes in.
Okay.
Each layer in MQIP
Right.
isn't just a simple stacking of information.
Okay.
It's a simplified, compressed version of the one below.
Hmm.
Think about taking a high-resolution photo
Way.
and shrinking it down for your phone.
Right.
You lose some detail, but the essence remains.
Okay.
Each layer of reality,
Yeah.
according to MQIP, does something similar.
So each layer is like a compressed file of the one before it, keeping only the most essential information.
Right.
I'm guessing that selection process plays a big role here.
Exactly.
Okay.
MQIP proposes that there's this selection mechanism,
Right.
perhaps governed by mathematical rules,
Okay.
that chooses the most efficient representation for each layer.
Right.
This selection process aims to minimize information loss while maximizing efficiency.
Now, our listeners should know we got pretty deep into some serious math in the source material for this deep dive.
Absolutely.
Category theory,
Yep.
topology information theory.
A lot
There's
of
a lot to process.
heavy hitters.
Yeah.
Those mathematical concepts are crucial
Okay.
for describing how these different levels relate to each other.
Right.
For example, category theory helps us understand how information is categorized and transformed as we move between layers, kind of like creating a map of reality structure.
So instead of just saying category theory is about boxes and arrows, we're talking about using it to map out how, say, the properties of space-time emerge from the quantum realm.
Exactly. Give us a concrete example.
Yeah.
Imagine you have a category for quantum states
Okay.
and another for space-time geometries.
Got it.
Category theory allows us to define the rules and relationships between these categories, essentially providing a mathematical language
Right.
for describing how one level can give rise to another.
That's much clearer.
Okay, good.
It's not just abstract math.
Right.
It's a way to understand the underlying structure of reality,
Right.
according to MQIP.
According to MQIP.
But to be honest, my brain's starting to feel like one of those compressed files we were talking about.
Yeah.
There's a lot to take in.
It's definitely a dense topic.
Yeah.
And it's important to remember that MQIP is still a very young and speculative theory.
Right.
There's a lot we don't know,
Okay.
and plenty of debate within the scientific community about its validity.
So we're not presenting this as the definitive answer to the universe's mysteries.
Definitely not.
Wow.
This is an exploration of a fascinating and potentially revolutionary idea.
Yeah.
We're dipping our toes into some pretty deep waters here.
Well, with that in mind, I think we need to unpack some of these mathematical concepts a bit further.
Okay.
This cake analogy is a good starting point.
Yeah, it's a good visual.
But I have a feeling the recipe gets pretty complicated.
It certainly does.
Yeah.
But that's what makes it so intriguing.
Hmm.
And who knows, maybe by the end of this deep dive, we'll all have a slightly better grasp of the code that might be running reality.
The code of reality itself.
The code of reality itself.
All right.
That's the goal.
I'm ready for part 2.
Let's do it. So we're starting to see how MQIP suggests this hierarchical structure to reality,
Right.
with each layer built upon a compressed version of the one below.
Okay.
But how do these different layers actually interact? That's
Yeah.
where things get even more interesting.
It can't just be a simple case of stacking building blocks.
Right.
If we're talking about quantum information giving rise to space-time,
Right.
which then leads to particles and
Yeah.
eventually to us.
Yeah.
Well, it sounds like a pretty complicated recipe.
It's definitely not a linear process.
Okay.
MQIP suggests that these transitions between layers
Right.
are more about emergence than simple causation.
Okay.
It's not that the lower levels directly cause the higher levels,
Okay.
but rather the higher levels emerge from the complex interplay of information at the lower levels.
Okay, so instead of a straight line,
Yeah,
we're talking about a more complex, interconnected web of relationships.
exactly.
But how do those mathematical concepts we mentioned earlier help us understand this emergence?
That's where tools like topology come into play.
Okay.
Topology is concerned with the fundamental shapes and connections of information.
Right.
MQIP suggests that each layer's shape,
Okay.
in an abstract sense,
Right.
is derived from the topology of the level below.
Mhm.
It's like each layer is a blueprint derived from the one before it.
So we're not just talking about physical shapes,
No.
but about the way information is organized and connected within each layer.
Exactly.
But how does this apply to something like consciousness?
Right.
I mean, we touched on that earlier.
Yeah.
But I'm still not clear on how MQIP could shed light on something so mysterious.
Well, if we consider consciousness as an emergent property of information processing,
Okay.
then MQIP provides a framework for understanding how it could arise from the interactions of neurons in our brains. It suggests that consciousness might be a kind of quotient space itself,
Okay.
a simplified higher-level representation of the complex information processing happening at the neural level.
So our brains are constantly taking in sensory input,
Right.
filtering and compressing information.
Yeah.
And somewhere in that process, consciousness emerges.
That's the idea.
It's like saying the hardware is important,
Yeah,
but the software, the algorithms, are what really make consciousness possible.
that's a good analogy. And it highlights how MQIP encourages us to look beyond just the physical structures of the brain
Right.
and consider the way information is processed and transformed.
Mhm.
It's not just about the neurons themselves,
Right.
but about the patterns of information flow
Okay.
and the complex dynamics that emerge from those patterns.
It's like saying that our individual perceptions of reality
Yeah.
are themselves kind of quotient space, a simplified version of what's actually out there.
Exactly.
We're always living in a filtered,
Right.
compressed version of the universe.
Precisely.
And if MQIP is correct,
Right.
that might be true not just for our individual perceptions,
Yeah.
but for the very fabric of reality itself.
Exactly.
Each layer from the quantum realm to the world we experience
Right.
might be a kind of quotient space.
A compressed representation that preserves the essential information while filtering out the rest.
So we're not just talking about a new way of understanding physics or consciousness, but a completely different way of thinking about reality itself.
It's a potential paradigm shift.
It sounds like we're on the verge of a major paradigm shift.
It's certainly a possibility. But again, it's important to emphasize that MQIP is a very young theory.
Okay.
There are many unanswered questions,
Right.
and it's still subject to intense scrutiny and debate within the scientific community.
Right. We're not saying this is the final word.
Right.
Just a fascinating new perspective that might open up whole new avenues of exploration.
Yeah.
It's like we've been given a new lens through which to view the universe. And suddenly things are starting to look very different.
Yeah, I like that analogy.
But all this talk about information compression and emergent properties,
Right.
it makes you wonder about the implications for us as humans.
Yeah.
Where do we fit into this grand scheme of information processing?
That's a question that takes us to the heart of some very profound philosophical issues, like the nature of free will
Okay.
If reality is built on layers of information processing.
Does that mean our choices are predetermined? Or is there room for agency within this cosmic code?
That's a pretty big question to grapple with.
It is.
If we're essentially running on a program,
Right.
does that mean our choices are predetermined?
Right.
Where does free will fit into all of this?
Yeah, it's a question that has puzzled philosophers and scientists for centuries.
Right.
And MQIP certainly adds another layer of complexity.
Yeah.
Some interpretations of MQIP might lean towards determinism, suggesting that our actions are ultimately determined by the underlying information processing.
So like a computer program running its course.
Yeah.
Everything is pre-programmed.
Yeah.
No room for deviation.
That's one way to look at it, but even within a deterministic framework,
Okay.
there might be room for a different understanding of free will.
Okay.
For example, some argue that even if our choices are determined by the information processing in our brains,
Right.
those choices are still our choices.
Arising from our unique experiences and the complex interplay of information that makes up who we are.
So even if there's a code, it's such a complex and nuanced code that it allows for the emergence of individual agency.
Right.
It's not just a simple input-output system.
Exactly. And it's worth remembering that even within the framework of physics, there's still debate about the true nature of determinism,
Right.
especially at the quantum level.
Right.
MQIP doesn't necessarily resolve these debates,
Okay.
but it provides a new perspective from which to approach them.
It's like saying that even if reality's running on a code, there might be enough wiggle room within that code,
Yeah.
enough flexibility and emergent complexity to allow for genuine choice.
Yeah.
We're not just automatons blindly following a script.
Precisely. And it's important to note that MQIP itself doesn't take a stance on the question of free will.
Okay.
It's a framework for understanding the structure of reality.
Right.
And how different levels of complexity might emerge from simpler building blocks.
Right.
The philosophical interpretations are still very much open to debate.
It feels like we've stumbled onto one of those classic philosophical debates, but with a whole new set of tools and concepts to consider.
It is.
It's both exciting and a little bit daunting.
Absolutely.
Yeah. Well, we've gone from reality as a cake to the mysteries of consciousness and the complexities of free will.
Right.
It's been quite a journey.
Yeah, it has.
Any final thoughts for our listeners before we wrap up this deep dive into MQIP?
I think the most important takeaway is that this is just the beginning of the exploration. MQIP is a young theory, and there's still so much we don't know.
Right.
But the ideas it presents are fascinating and thought-provoking.
Yeah.
And they have the potential to revolutionize our understanding of the universe and ourselves. If anything, I hope this deep dive has sparked a sense of curiosity and wonder.
Yeah.
Keep questioning,
Okay.
keep exploring, and keep your mind open to the infinite possibilities that reality might hold.
Well said. And for our listeners who are eager to delve deeper into this mind-bending world of MQIP, we've included links to all the source material in the show notes.
Absolutely check those out.
So go forth, explore, and let us know what you discover.
Yeah, we'd love to hear from you.
Until next time, keep searching for the hidden code that might just be running the show.
Time for a small commercial break. Please feel free to pause if you have to. Otherwise, part 2 commences.
Hey everyone, are you ready for another deep dive? This time, you've given us an amazing collection of sources all about definition and existence.
Oh yeah, it's a really interesting mix. We've got philosophy, neuroscience, even some notes on quantum physics.
Yeah, it's wild. It's like you're challenging us to figure out if how defining things shapes reality itself.
Exactly, and that's what makes this deep dive so fascinating. We're not just talking about looking up words in a dictionary.
Yeah.
We're talking about how our brains label and categorize the world and how that might connect to the very fabric of the universe.
Whoa. Okay, so where do we even begin with all of this? One of the sources starts with something I think we can all relate to, that feeling of flow when you're totally absorbed in an activity.
Oh, I love that feeling.
Right. It's the best. And the source says it has something to do with letting go of rigid self-definitions. It even uses this cool metaphor like, water can flow or it can crash. What do you think they mean by that?
That's a good one. It reminds me of the idea that trying to overdefine everything can actually be counterproductive,
Yeah,
Imagine if you were constantly labeling your every thought and action, you'd never get anything done.
it's true.
There's this school of thought called phenomenology, which says that our lived experience is what shapes reality. And in those flow states, you're not weighed down by labels, you're just directly experiencing the activity itself. the isness of it.
Oh, I see. So it's like when you're so focused on a project that you lose track of time.
Yes.
You're not thinking, I am a painter. You're just painting.
Exactly. You're just in the moment, fully immersed in the experience.
Yeah.
And that seems to open up possibilities that rigid definitions might close off.
That makes sense. And speaking of things that define our reality, what about the brain? The sources describe it as this ultimate observer that defines and interprets everything for us.
Yeah, the brain is like the ultimate definition engine. Think about the prefrontal cortex, which is essential for planning and decision-making. It's heavily involved in labeling and categorizing concepts, helping us make sense of the world.
So it's not just about passively receiving information.
Right.
It's about actively shaping it based on our existing categories and labels.
Exactly. And the basal ganglia, which helps us choose our actions, is also influenced by these definitions. So our brains are constantly framing everything we experience, almost like a filter that shapes what we perceive as real.
Wow, that's kind of trippy.
It is. And it's sort of similar to how in quantum physics, the act of measuring something seems to collapse the wave function, forcing it to choose a single state.
Okay, so are we saying our brains are shaping reality itself, like some kind of superpower?
That's where things get really interesting. The sources suggest this definition process might not just be happening in our heads. It could be happening at the level of the universe itself.
Hold on, are you saying the universe is like defining itself? How does that even work?
Well, one source points out that the universe might not just passively follow physical laws. It might actively favor self-organization and adaptation. Think about how life emerged from non-living matter, or how complex systems evolved from simpler ones.
So instead of just randomness, there's a tendency for things to become more ordered and complex over time.
Exactly. And that leads to the mind-blowing idea that the universe could be a self-optimizing computational system.
Like a giant computer.
Yeah, kind of, where selection acts as a kind of filter, shaping what we observe at different scales.
Okay, that is mind-blowing. But how does all this actually work in the brain itself?
Well, one source puts it this way. If you're searching for the physical basis of consciousness, start by looking at gray matter.
All right, let's get into the nitty-gritty of the brain then. What's so special about this gray matter?
So picture the outer layer of your brain, the cortex. It's not smooth, it's incredibly wrinkled with all these folds and grooves.
Oh yeah, I've seen pictures of that. It's crazy.
And those wrinkles actually increase the surface area, packing in a massive amount of neurons and connections, which are concentrated in the gray matter.
More wrinkles, more brain power.
I
like it. But how does that relate to consciousness?
Well, these dense connections, called synapses, form the computational substrate of the brain. It's not just about individual neurons firing.
Right.
It's about how they're connected and how information flows through those networks.
So the gray matter is like the hardware that runs the software of our thoughts and perceptions.
That's a great way to put it.
Yeah.
And the source emphasizes that the cortex has this layered structure that's crucial for both specialized tasks and integrating information. It's like different departments in a company, each with its own expertise, but all working together to achieve a common goal.
That makes sense. We've got different areas for vision, language, memory, and they all have to work together to create a unified experience.
Right. And the communication between those areas is incredibly complex.
Yeah.
We've got electrical signals zipping between neurons and chemical messengers called neurotransmitters bridging the gaps.
So it's a symphony of signals going on in there.
It is. There's a delicate balance between excitatory and inhibitory signals, like a symphony orchestra where different instruments play together in harmony.
So if the brain is an orchestra, where's the conductor? Is there a single area responsible for consciousness?
That's the million-dollar question. The sources mention a few key players, though. The thalamus is like a relay station, filtering sensory information before it reaches the cortex.
So it's deciding what gets our attention, what makes it to the conscious level.
Exactly. And then there's the claustrum, this thin sheet of neurons that some researchers think might be the conductor, coordinating activity across different areas of the cortex.
And making sure all the instruments are in sync.
Right. And of course, we can't forget the brainstem, which is responsible for basic arousal, keeping the lights on, so to speak.
Right. Without that, we wouldn't be having this conversation.
Exactly.
So it seems like consciousness is more like a symphony than a solo performance with all these different brain regions working together.
Absolutely. And one of the most amazing things about the brain is its plasticity. It's not static.
Yeah.
It's constantly changing and adapting based on our experiences.
Like how we learn new things and form new memories.
Exactly. The source talks about synaptic plasticity, where the connections between neurons get stronger or weaker depending on how often they're used. It's like building a muscle. The more you use it, the stronger it gets.
So our brains are literally being reshaped by our experiences, which in turn shapes how we experience and define reality.
It really is. And the source points out that this plasticity is crucial for how conscious experiences and personal identity shift over time.
So we're not the same person we were 10 years ago because our brains have literally changed.
Right. Your brain, and therefore your sense of self, has been shaped by everything you've learned and experienced.
Okay, so we've established that the brain is this complex, dynamic system that plays a crucial role in how we define reality. But one of the sources introduces a new concept that I find truly fascinating, the Quotient Isomorphism Principle, or QIP.
Oh yeah, QIP. That's a good one.
It can be a bit complex, but it's worth the effort to understand.
Totally.
So what is QIP all about?
The basic idea is that consciousness emerges when the brain creates a compressed representation of reality that still manages to preserve the most important relationships.
A compressed representation, like zipping a file on a computer.
That's actually a really good analogy. Think about how a zip file shrinks a large amount of data down to a smaller size, but you can still unpack it and get all the original information back.
So our brains are taking the complexity of reality and creating a simplified version that's easier to manage, but it still captures the essence of things.
You got it. This process of reducing complexity while maintaining key features is called quotient mapping.
Okay, I think I'm starting to get it, but how does this connect to consciousness?
Well, QIP suggests that consciousness arises when the brain's internal model, let's call it GR, is structurally isomorphic to the full complexity of reality, which we can call G.
Isomorphic, does that mean they're identical in structure?
Precisely. Imagine you have two different maps of the same city. They might look different with different levels of detail, but they both represent the same underlying relationships between streets, buildings, and landmarks.
Okay, so our conscious experience is like a simplified map of reality, but it's still accurate in terms of the relationships between things.
That's the gist of it. And one of the sources makes a pretty bold statement based on this. This suggests that reality is computational in its structure.
Whoa, hold on. Are they saying the universe is like a giant computer constantly calculating and processing information?
It's not quite that simple, but the idea is that reality might operate like a self-compressing information system.
Okay, I'm trying to wrap my head around this.
Yeah, it's a big idea. There might be a sort of cosmic algorithm that's constantly filtering and selecting information, shaping what we observe at different scales.
So maybe the universe isn't a giant brain, but it might be a giant computer. This is getting pretty deep.
It is, but it's just the beginning.
I can't wait to see where we go next.
Me too. There's a lot more to explore. Welcome back. Last time we were grappling with some pretty big ideas. The universe is a giant computer, the role of definition and shaping reality, and that whole debate between randomness and a deeper selection process.
Yeah, it was a lot to take in. That quantum measurement problem really had my head spinning. It seems like the whole discussion boils down to this question of, like, is the universe just passively allowing structure to emerge, or is it actively selecting for it?
You've hit the nail on the head. And one of the sources actually introduces a framework that might help us understand this tension, the Meta Quotient Information Principle, or MQIP.
MQIP, okay, that sounds pretty intense. But remind me, QIP was all about the brain creating a compressed representation of reality, right? Like that zip file analogy we talked about.
Exactly. But MQIP takes that idea a step further. It suggests that this same principle of quotient mapping, compressing information while preserving those essential relationships, might apply to reality itself across multiple scales.
Wait, so instead of just the brain creating a simplified map of reality, maybe the universe is doing it too. Like, the universe itself is a giant multi-layered zip file, constantly compressing and decompressing information.
That's a fantastic way to visualize it. The source even presents a mathematical equation to represent this, where each layer of reality, from the quantum realm to the cosmos, is represented by a type and a system that manifests that type at a particular scale.
So you've got different levels of reality, like physics, biology, computation, even cognition.
Yeah.
And they're all connected through this scaling function that compresses and decompresses information. It's like a cosmic zoom lens changing focus depending on the scale you're looking at.
Precisely. And this MQIP framework might help explain why reality appears so different at different scales, yet still follows these similar patterns of selection and organization.
So even though quantum physics, biology, and consciousness seem like totally different things, they might actually be governed by the same underlying principle.
That's the idea. The source even lays out this fascinating hierarchy, quantum reality, as the base layer, physics emerging as a selection of stable structures from that layer, then biology emerging as a self-propelling system that further selects from physics, and so on. It culminates with cognition merging as a kind of recursive quotient, self-referencing its own informational selection.
Whoa, okay, my brain needs a minute to catch up, but it sounds like each layer is basically a filter that selects and shapes information from the layer beneath it.
You got it. It's like each level of reality is a bandpass filter, allowing certain frequencies of information to pass through while blocking others. That filtering process is what creates the structure and order we observe.
So physics filters quantum possibilities, biology filters physical possibilities, computation filters biological possibilities. It's like a cosmic game of telephone where the message gets refined with each transmission.
And importantly, the source emphasizes that this filtering process isn't random. It follows these specific rules to ensure self-consistency and stability at each level.
So it's not just a matter of chance that we have the laws of physics we do, or the types of life we see on Earth. There's a deeper principle at play guiding the emergence of complexity.
And that brings us back to the question of intent. MQIP doesn't explicitly say there's a conscious mind directing this selection process, but it suggests that reality itself has this self-referential, intentional element built into its very structure. Like the act of selection implies some kind of preference, some criteria for choosing one outcome over another.
I'm trying to picture this. If this selection is happening at every level of reality, from the tiniest quantum event to the formation of galaxies, it's like the universe is constantly making choices, shaping itself as it goes. It's a pretty radical departure from that idea of a clockwork universe that just blindly follows predetermined laws.
It definitely challenges our traditional assumptions about how reality works. So if we accept this MQIP framework, what are the implications?
Well, for starters, it means that reality isn't just physical stuff, right? The physical world emerges from a deeper level of information processing, and even biology itself seems to be guided by these computational principles.
Precisely. We're not just material beings governed by these blind physical laws. We're part of this multi-layered system where information and selection play a fundamental role. Even our own consciousness, it seems, is an emergent product of this process. It's not just an accidental byproduct of biology, but an emergent quotient that inherits these biological constraints, but optimizes for abstract thought and information processing.
Okay, my brain is officially doing backflips right now. This is a lot to absorb. But I have to ask, how can we be sure this MQIP idea is actually true? Is there any way to test it scientifically?
That's the challenge with any theory that pushes the boundaries of our current understanding. But one of the sources presents a fascinating argument using proof by contradiction to demonstrate that an observer, or an equivalent selection mechanism, must exist at all scales of reality.
Ooh, I love a good proof by contradiction. Walk me through how it works in this case.
The argument starts by assuming the opposite of what we want to prove. So in this case, we assume there is any DO observer persisting at all scales of reality.
Okay, so we're starting by saying that reality just exists out there, without any need for selection or interpretation.
Exactly. Then we examine the implications of this assumption at different scales, starting with the quantum realm. We already know that observation, or at least interaction, is necessary to collapse the wave function and produce those definite outcomes in the quantum world.
Right. We talked about that earlier. Even at the quantum level, there's this evidence that something is choosing which possibilities become real.
Precisely. And as we move up to the biological scale, we see even more evidence of selection at play. Living organisms actively choose these favorable energy states to survive and reproduce. Evolution itself is a testament to the power of selection, where organisms with advantageous traits are more likely to pass on their genes.
It's like natural selection is acting as an implicit observer, guiding the course of evolution over millions of years.
Exactly. And when we move up to the cognitive level, the idea of an observer becomes even more obvious. Our brains are constantly filtering, selecting, and interpreting information, creating our subjective experience of reality.
Yeah, I mean, we can't be aware of everything at once. Our brains have to choose what to focus on, what to ignore, and how to make sense of it all.
Right. And even forming a simple thought requires an observer, an internal eye, that's aware of its own mental states. So even our thoughts are, in a sense, a product of observation and selection.
Wow, so we're observers even within our own minds. But what about reality as a whole?
That's where the source takes us next to the metacognitive level. If there were no observer at any scale, how could reality maintain its self-consistency? Why do we see these specific patterns and structures emerge rather than just pure chaos and randomness?
It's like you're saying, if nobody's watching, shouldn't the universe just be this random mess?
That's the point. And this leads us to conclude that there must be this overarching selection principle operating at the highest level of abstraction, shaping the universe as a whole.
So by assuming there's no observer at any scale, we run into these contradictions at every level. Therefore, the observer must exist at every level of reality.
That's the conclusion of the proof by contradiction. It's a powerful argument for the idea that reality is fundamentally structured as an observer-dependent system. This ties back to MQIP, and that notion that selection is woven into the fabric of existence itself.
Okay, so we've got MQIP suggesting that reality is this multi-layered, self-defining system, and we've got this proof by contradiction showing that observation is inherent to reality. But where does consciousness fit into all of this? Is it just this passive byproduct of these processes, or does it play a more active role?
That's the million-dollar question. And one of the sources tackles this by looking at the relationship between existence and definition from a philosophical standpoint.
All right, let's get philosophical then. How do philosophers view this connection?
The source points out that the question of existence has been a head-scratcher for philosophers for centuries. It's this slippery concept that's hard to define precisely. I mean, what does it really mean for something to exist?
Yeah, that's a good question. We can imagine things that don't exist in the physical world, like unicorns or fictional characters. So what makes something real?
The source explores this through different philosophical lenses: ontology, epistemology, logic, even linguistics.
Let's start with ontology. What's that all about?
Ontology is basically the study of being, what kinds of things exist, what are the fundamental categories of reality, how are different entities related to each other. It's like trying to create a map of everything that is.
So it's about classifying and categorizing everything that exists. But how does that help us understand the connection between existence and definition?
Well, one problem is the question of ontological commitment. What does it mean for us to be committed to the existence of something? Do we only accept the existence of things that can be empirically verified? Or can we also be committed to these abstract entities, like numbers or concepts?
It's like we're trying to draw boundaries around what we consider real, and those boundaries can be fuzzy.
Exactly. And the source points out that our definitions of what counts as existing are always evolving. What we consider real today might have been considered purely hypothetical in the past, and vice versa. Think about how our understanding of the universe has changed over time.
So our understanding of existence is constantly expanding, influenced by new discoveries and new ways of thinking.
Right. And that brings us to epistemology. How do we know what exists? What are the sources of knowledge? How can we be sure our beliefs about reality are accurate?
Yeah, our senses can deceive us and our minds can create illusions. So how can we be sure we're not just making things up?
The source explores these different philosophical approaches to knowledge, from empiricism, which emphasizes sensory experience, to rationalism, which prioritizes reason and logic. It's all about how we justify our beliefs about the world.
So it's not just about what exists, it's about how we come to know it and how we can be sure our knowledge is reliable. But how does this relate back to definition?
The source argues that our knowledge of what exists is always limited by our ability to define and conceptualize it. Like, if we can't even imagine something, how can we know if it exists?
That makes sense. We need language and concepts to grasp reality, but those tools might also limit our understanding.
Precisely. And that leads to the limitations of language itself. Our words and concepts are these human constructs, and they might not perfectly capture the fullness of reality. Different languages might even shape our understanding of existence in different ways, leading to different cultural conceptions of what's real and what's not.
So our very language might be shaping how we perceive and define the world around us. This is getting deep. But I remember the source also talked about a distinction between being and existence. What's the difference?
Good catch. Being is a broader category, encompassing anything that can be said to be, regardless of whether it exists in the physical world. This includes abstract entities, concepts, even fictional characters.
So being is about possibility, while existence is about actuality.
That's a great way to put it. This distinction helps us navigate that tricky relationship between existence and definition. We can say that the concept of justice is, without necessarily claiming it exists in the same way as, say, a tree.
Okay, so we've explored the philosophical side of things, but I know the source also brought in some insights from science, particularly physics.
You're right, and this is where things get really interesting. The quantum world throws a major wrench into our classical understanding of existence.
Because in quantum mechanics, things don't exist in this definite state until they're measured. It's like reality is blurry until someone looks at it.
Exactly. And this challenges the traditional view where things are assumed to exist independently of observation. It raises these profound questions about the nature of reality and the role of consciousness in shaping it.
So does this mean existence is subjective, that it all depends on the observer?
It's a tempting conclusion, but it's more accurate to say that quantum mechanics reveals the limits of our classical intuition about reality. It shows us that we can't neatly separate the observer from the observed, especially at the quantum level.
I'm starting to see how all these pieces fit together, from flow states to the brain to quantum mechanics. It's like we're building a case for the idea that definition plays a crucial role in shaping reality.
Exactly. And one of the sources introduces a concept that takes this idea to a whole new level, the idea of reality as a self-defining loop.
A self-defining loop. Okay, now I'm really intrigued. What does that even mean?
The source argues that the question, who defines in a reality without observers, highlights this major tension in our understanding of existence. If existence depends on definition, who's doing the defining if there's no one around to do it?
Yeah, that's a mind bender. It's like a chicken and egg problem. Which came first, the definer or the defined?
Precisely. And the source presents two contrasting viewpoints on this question. The first viewpoint, which we might call the theistic perspective, argues that the loop must be closed by something outside of reality itself.
So there must be some ultimate definer, some cosmic consciousness that sets the rules and establishes what exists. It's like saying there needs to be a god to get the whole thing started.
Right. That's one way to look at it. But the contrasting viewpoint, which we might call the atheistic perspective, argues that reality is self-defining. There's no need for an external observer or a cosmic consciousness.
So how do they explain the emergence of order and structure without appealing to a higher power?
They argue that reality operates based on these causal, emergent, or recursive principles. For example, they point to physics, where quantum decoherence, the interaction of particles with their environment, causes the wave function to collapse into these definite states.
So the environment itself acts as the observer, selecting which quantum possibilities become actualized. It's like saying that reality defines itself through its own internal interactions.
Exactly. And they extend this idea to the mind, arguing that neural networks self-organize and create our subjective experience of reality. It's all this giant feedback loop, with no need for an external definer.
But doesn't that just push the problem back a level? If the environment is the observer for quantum events, who's observing the environment? And who designed the laws that govern those interactions in the first place?
You hit on a key point. The source acknowledges that this debate ultimately hinges on this fundamental question. Can reality define itself purely from within, without anything beyond itself?
Because if it can't, then something outside of reality, some kind of cosmic consciousness or intelligence, must exist to close the loop. We're back to the God question.
It's a question that naturally arises from these ideas. But even without invoking a divine creator, that concept of reality as a self-defining, self-organizing system is incredibly profound. It suggests that the universe isn't just this random collection of particles and forces, but a deeply interconnected, purposeful entity that's constantly evolving and refining itself.
Okay, so we've got these two opposing viewpoints, reality as a self-defining loop versus reality requiring an external definer. But I remember the source also mentioned something about the collapse of photons being a form of computation. Can you elaborate on that?
Absolutely. This is where the lines between physics and information theory really start to blur. The source describes this experiment where photons are sent through this complex maze of mirrors and beam splitters. The path each photon takes depends on its polarization, this quantum property that can be measured.
So we're talking about tiny particles making decisions, navigating a maze based on the quantum properties.
In a sense, yes. And here's where it gets really interesting. The experiment is designed so that the final outcome, whether a photon ends up at detector A or detector B, depends on a specific computation.
So the photons are essentially performing a calculation by navigating this maze. It's like they're solving a problem.
Exactly. And the source emphasizes that this isn't just a metaphor. The photons are physically enacting this specific computational process.
Okay, now my mind is officially blown. How does this relate back to definition and existence?
The source argues that this experiment demonstrates that quantum measurement isn't just a passive collapse. It's a form of computational selection. The universe isn't just randomly spitting out outcomes. It's actively choosing based on these specific rules and computations.
So the act of measurement itself is a kind of computation, and that computation is what defines reality. It's like the universe is constantly asking questions and computing the answers, shaping itself through that process of measurement.
That's a powerful way to think about it. And it leads to this radical new perspective. What if reality itself is fundamentally informational? A vast computational system where information is the primary substrate and physical laws are just emergent properties of this underlying information processing.
Okay, now we're really down the rabbit hole. So instead of a universe made of matter and energy, it's more like a universe made of bits and algorithms.
It's a mind-bending concept, but it has the potential to revolutionize our understanding of reality.
Okay.
And it brings us back to that question of intent. If measurement is a computation, and computation is an act of defining meaning, then measurement is a form of cognition happening at that fundamental level of reality.
So are we saying that the universe is conscious?
That's a question that will likely be debated for centuries to come. But this experiment, along with that MQIP framework we discussed earlier, suggests that reality is far more complex and mysterious than we ever imagined. And it opens up the possibility that consciousness, or something akin to it, might be woven into the very fabric of existence itself.
Wow, I need a moment to process all of this. It's like we've gone from questioning how our brains define reality to questioning whether reality itself is this giant conscious computer.
It's been quite a journey. But I think one key takeaway is that the questions are just as important as the answers.
Because the more we learn, the more we realize how much we don't know, and that sense of wonder is what drives us to keep exploring.
Exactly. Join us next time as we continue to delve deeper into these mysteries and explore what this all means for our understanding of the universe, our place in it, and the very nature of existence itself.
Welcome back to the Deep Dive. We've been on quite a journey exploring how definition shapes reality, from our brains to the universe itself. Last time, things got really mind-bending.
Yeah, we were really getting into it, weren't we? Exploring different perspectives on existence, consciousness, that whole nature of reality thing.
And we even touched on the idea that even quantum measurements could be a form of computation, like hinting that the universe might be more like a giant computer than we ever imagined.
And remember how we discussed how the atheist scientist might try to explain away this choice of measurement basis by appealing to pure randomness?
Right, but that argument runs into some problems, right? Especially when you try to explain the stable, predictable world we actually experience. Like, if everything were truly random, wouldn't things be a lot more chaotic and unpredictable?
Exactly. One of the sources points out that the atheist's reliance on randomness is actually a form of selection itself. It's like saying, I choose to believe that there's no choice.
So by rejecting the idea of some deeper principle or intent behind the universe, they're implicitly making a choice. They're choosing to define reality as fundamentally random and purposeless. But does that really align with what we observe in the world around us?
That's the question, isn't it?
Oh.
Think about the incredible fine-tuning of physical laws, the emergence of life, the development of consciousness. Those don't seem like random accidents.
It's like there's this hidden intelligence at work, kind of guiding the process of creation and evolution.
And one of the sources offers a helpful framework for analyzing these deep debates. They call it a 5-layer decomposition model.
Okay, I like that, breaking things down. What are the 5 layers?
They are the ontological, epistemological, computational, intentional, and meta-reflexive layers.
Those are some big words. What do they all mean?
So the ontological layer focuses on the question of what exists, what's actually real.
Mm-hmm.
The epistemological layer deals with how we know what we know, like how do we even know anything for sure. The computational layer explores the processes that govern reality. What are the rules of the game, so to speak? The 4th layer is intentional. It asks if there's a direction or preference driving those processes, like is there a purpose behind it all? And finally, the meta-reflexive layer examines whether the debate itself becomes self-referential. It gets pretty meta.
Okay, so it's like we're peeling back the layers of an onion, going deeper and deeper into the heart of the debate.
Exactly. So let's see how this model applies to our discussion about definition and existence. On that ontological layer, the atheist might say that reality is fundamentally random and emergent, while someone with a more theistic viewpoint might argue that there has to be some kind of selection process guiding the collapse of possibilities into actuality.
So is it chance or is it choice?
Right. And on the epistemological layer, the atheist might adopt this stance of instrumental realism, arguing that the best model is simply the one that predicts reality most accurately, regardless of whether it reflects some deeper truth.
So they're saying if it works, it works.
Yeah, kind of. Someone with a theistic perspective might counter that the existence of these consistent laws and patterns suggests a more profound metaphysical basis for knowledge.
So it's a question of whether our knowledge is purely pragmatic or whether it reflects something deeper about the nature of reality.
Exactly. Now, on the computational layer, The atheist might see the universe as an unconscious information processor, where quantum decoherence simply destroys superpositions and creates classical reality. But someone with a more theistic viewpoint might question why we have these specific laws of physics and this particular computational structure, hinting at an intelligence behind the design.
It's like the difference between a computer running a random program versus a computer that's been designed to achieve a specific goal.
That's a great analogy. On the intentional layer, the atheist might argue that selection is just an illusion, a byproduct of statistical survival. But someone with a theistic perspective might point to the universe's apparent preference for order and complexity as evidence of a deeper teleological principle at work.
So is the universe indifferent to outcomes, or is it guided by a sense of purpose?
Right. And finally, on that meta-reflexive layer, the atheist might suggest that this whole debate is just a product of our human cognitive biases.
Like, our brains are just wired to see patterns and purpose even where they don't exist.
Exactly. But someone with a theistic perspective might argue that the very act of defining reality is itself a form of measurement and selection.
Okay, so now we're debating the debate.
It can get pretty meta. This 5-layer model helps us see just how complex these questions really are. There are layers upon layers of interpretation, and ultimately, it comes down to how you choose to see the world.
It definitely seems like the evidence from physics, cosmology, biology, even our own conscious experience points toward a reality that's far richer and more mysterious than a purely materialistic worldview can account for.
I agree, and that idea that definition itself might be an inherent feature of reality, not just a human construct, that's a really profound one. It suggests that we're not just these passive observers of the universe, but active participants in its ongoing process of self-definition.
Wow. This has been an incredible journey. We've explored so many mind-bending ideas, and I feel like I have a whole new perspective on reality.
Me too. And I think one of the biggest takeaways here is that the questions are just as important as the answers. The more we learn, the more we realize how much we don't know. And that's what makes exploration so exciting.
So to everyone listening out there, keep questioning, keep exploring, and keep diving deep into the mysteries of the universe. Who knows what incredible discoveries await us just beyond the horizon?
Time for a small commercial break. Please feel free to pause if you have to. Otherwise, Part 3 commences.
Welcome to the Deep Dive. We've got some really fascinating stuff to unpack today, all about MQIP. That's the Meta Quotient Information Principle.
Yeah, it's definitely a hot topic right now, causing a real stir.
From what I've seen, you've been digging deep into how our whole view of the universe might be changing. So, MQIP, in a nutshell, what's the big idea?
At its core, it's the idea that reality, well, it isn't just sitting out there waiting to be observed. Instead, it's being actively shaped by information. And this selection process, it's happening everywhere. I mean, everywhere, from tiny particles to the whole vast cosmos.
So information isn't just describing reality, it's actually like a fundamental part of how reality works.
That's the radical bit, yeah. Think of reality like some kind of, I don't know, multi-layered information system. Each layer, it's like a simplified version of the one below it, a quotient. Like, you know how a world map is way simpler than a super detailed topographical map, right? But you can still use it to find your way.
Okay, I think I see where you're going with this.
So MQIP says this mapping, this quotient thing, it applies all the way from quantum states up to, well, our own consciousness, each layer emerging from the one below. Through this process of selection, like reality is constantly choosing which information matters most.
Wow, that's pretty mind-blowing. Where did this MQIP idea even come from?
It's relatively new, actually. It comes from research across a bunch of fields. Quantum mechanics, neuroscience, information theory, all that. Scientists and philosophers, they were hitting these roadblocks, these weird things they couldn't explain, and they started to see a pattern.
Oh, interesting. So different fields kind of pointing towards the same underlying principle.
Exactly. It's not just some random idea. It feels like a real scientific theory, one that we're starting to back up with actual data.
All right. Color me intrigued, but I gotta admit, I'm a bit skeptical too. This is all pretty abstract stuff. What kind of evidence is there for all of this?
That's the question, isn't it? One of the most compelling pieces comes from quantum mechanics, specifically the delayed choice quantum eraser experiment.
I've heard of that, but honestly, never quite grasped it. Something about photons, right?
Yeah, those particles of light. So this experiment shows that observing a photon, just looking at it, can actually affect how it behaved in the past. As if reality is like choosing its path based on us watching, like the future is influencing the past.
Wait, hold on. How can the future influence the past? That messes up the whole cause and effect thing.
It's wild, right? But that's what the data seems to show. Basically, they send a photon through this setup where it can take one of two paths. Later on, we get to choose if we want to erase the info about which path it took. The crazy part is, the photon's behavior at the very beginning seems to depend on what we choose to do later. Like it knows what we're going to do.
That is seriously freaky. So we aren't just influencing it in the present, our choices in the future are somehow affecting its past.
Exactly. And this is where MQIP comes in. It says this isn't just some weird quantum quirk. This is a fundamental principle of reality itself. Information and selection, they're baked into the fabric of the universe at the deepest level.
Okay, I see why this is turning things upside down. It's like our everyday idea of how things work is being completely rewritten.
Right, and it has huge implications. If MQIP is true, we aren't just passive bystanders in reality, we're actively shaping it, even at the subatomic level.
So just by observing something, we're affecting its reality.
Looks like it. And it's not just the quantum world. MQIP suggests that this whole information and selection thing, it's happening in our own brains all the time.
Okay, how does MQIP explain how our brains work then?
Well, more and more, neuroscience is showing that our brains aren't just passive receivers, taking in whatever comes at them. They're actively constructing our reality through selection, filtering, interpretation.
So our senses aren't just limited. Our brains are actually choosing what to focus on and how to make sense of it.
Exactly. Imagine walking down a busy street. You're flooded with sights, sounds, smells, everything. But your brain, it can't process all that at once. It has to pick and choose what's important, what helps you survive, what aligns with your goals.
So like our brains are these super efficient editors, taking the raw footage of reality and cutting it into a story we can understand.
Perfect analogy. And it's this editing process, this selecting and interpreting, that creates our own unique experience of reality, our personal reality.
So there's not one objective reality out there, just a bunch of different versions based on how our brains filter things.
Precisely. And this is where things get really interesting from an MQIP point of view.
Okay, lay it on me.
If our brains are constantly choosing and interpreting, what's guiding those choices? What makes something important enough to pay attention to?
Good question. What does MQIP say about that?
MQIP says it's all about quotient-preserving isomorphism. Fancy way of saying our brains are trying to make a simplified but consistent model of reality, one that keeps the essential relationships between things.
So our brains are like building a mental map of the world.
Yeah.
And that map needs to be accurate enough to guide our actions, right?
Absolutely. And this map making, it's happening constantly at every level, from how we see objects to how we understand like time and cause and effect.
That makes me think about how differently people can see the same thing. Like, two people witness the same event, but come away with completely different interpretations.
Perfect example. Our personal stuff, experiences, beliefs, values, they all filter how we see the world. And that's where MQIP starts overlapping with psychology and, how we think.
So it's not just physics and neuroscience being shaken up by MQIP, it's our understanding of the mind itself, too.
Absolutely. MQIP gives us this whole new framework for how we think, how we decide things, how we even find meaning in life. And it's a framework built on information being the fundamental building block of everything.
Okay, my head is definitely spinning, but I think I'm starting to see how big this is. But before we get too philosophical, I want to bring it back to the science for a sec. You mentioned experiments to test MQIP. What do those look like?
That's what's exciting about MQIP. It's not just a cool idea. It's a scientific theory that we can test. And these experiments, they're happening all over. Quantum mechanics, neuroscience, even cosmology.
Wow, so it's a truly multidisciplinary thing. What are they specifically looking for? Where's the evidence?
Well, one area is those quantum erasure experiments we talked about. Scientists are using cutting-edge tech to really isolate how information gets compressed and selected, to see if the universe really is making choices based on information.
So it's like trying to catch the universe in the act of, thinking.
Haha, kind of. And in neuroscience, researchers are using brain imaging to see how different labels we put on things actually change how people see them.
So like if you tell someone they're looking at a snake, their brain processes it differently than if you say it's a rope, even if it's the same image.
Exactly. And if those labels really do change brain activity, that would be a strong point for MQIP. More evidence that we're actively building our reality based on information.
That is so cool. It's
Yeah.
like we're mapping out how reality gets constructed right inside the brain.
It gets even crazier. Scientists are using artificial intelligence to test MQIP too, building computer models to see if this self-referential quotient mapping thing can actually lead to intelligence, kind of mimicking evolution.
So like creating a mini universe in a computer and seeing if it starts to think on its own.
Kinda, yeah. Trying to build intelligence from scratch, using MQIP as the blueprint if they pull it off. Huge step towards validating the whole theory.
Okay, this is blowing my mind wide open. So MQIP isn't just about how the universe works. It could be a roadmap for understanding or even creating intelligence itself.
That's the beauty of it. And we're just getting started. We haven't even touched on its potential in, like, medicine, energy, space travel. The possibilities are endless.
I see why you're so fired up about this. This is a real deep dive.
It is, and we're just getting started.
So before we went off on that tangent, we were discussing how MQIP changes how we think about the brain. It's not just passively taking in info.
Exactly. MQIP is all about the brain being active. Selecting, filtering, interpreting, building our reality, really.
It's like our brains are making a custom movie of the world, cutting out all the boring parts and just showing us what matters.
Great analogy. And what's even cooler, this editing process, it's not random. It follows these rules, these principles to make sure the reality we experience is, well, stable and meaningful.
So it's not just what we see and hear, but also how our brains decide what it all means, right?
Right. Our brains are constantly searching for patterns, making predictions, filling in the gaps based on, what we've already experienced, what we expect to happen. And it all happens so smoothly we don't even realize it's going on.
Like our brains are running some complex algorithm in the background, making sure our reality runs smoothly, huh?
Exactly. And MQIP says this algorithm, this whole selecting and interpreting thing, is guided by quotient-preserving isomorphism.
Okay, gotta admit, that one still trips me up. Remind me what that means again.
It basically means that our brains want to make a simplified but accurate model of reality, like those maps we talked about. A world map is way simpler than the real Earth, but it still shows the important connections, continents, oceans, all that.
So our brains are doing the same thing, making mental maps that are good enough to help us navigate and make decisions.
Exactly. And it's not just for our physical surroundings either. It also applies to how we understand abstract stuff, time, cause and effect. Even our sense of self.
So how we see ourselves, our whole identity, that's also shaped by this information processing.
Seems like it.
Yeah.
MQIP says our sense of self comes from our brain trying to make a coherent story out of all the information it's getting, like a constantly updating narrative.
So we're the star of the movie our brain's directing, huh?
Yeah. And this has huge implications for how we think about consciousness, free will, the whole shebang.
Okay, that's getting pretty deep.
Yeah.
But before we wander off into the philosophical weeds, let's loop back to those experiments you mentioned.
Right. Remember, MQIP isn't just some thought experiment, it's testable.
What about biology, though? Can MQIP tell us anything about how life itself evolved?
Now that's where things get really interesting. Remember how MQIP says reality is like a stack of maps, each one simpler than the one below?
Yeah, starting to grasp that idea.
Well, some biologists are saying maybe evolution works the same way. All those levels, from cells to organisms to whole ecosystems. They might be quotients of each other, too.
So, like, an ecosystem is just a simplified version of all the craziness going on with individual creatures, right?
Bingo. And looking at it through this MQIP lens might help us understand how things get more complex, how new levels of organization pop up out of simpler ones.
So instead of evolution being random, MQIP says there might be some deeper principle guiding it, like information and selection.
That's the thought. It's all pretty new, but it's a totally fresh way to look at one of the biggest mysteries out there. How did life even start?
Makes me wonder about another big one, the origin of the universe. Any cosmological insights from MQIP?
Now we're going full cosmic. If MQIP's right, the universe isn't just expanding randomly, it's also processing information, selecting certain outcomes.
Hold on, are you saying the Big Bang wasn't just some random explosion, but like the beginning of a giant cosmic computation?
It's a radical idea, but yeah, that's kind of where MQIP takes us. Remember that quotient-preserving isomorphism thing? Well, if it applies to the whole universe, then maybe the way the cosmos is structured is a reflection of something deeper, something informational.
So the galaxies, the laws of physics, it's all a result of some cosmic selection process. It's not just random.
Exactly. And some people who really love MQIP even say the universe might be evolving towards like greater complexity and intelligence, driven by this whole information processing thing.
Whoa, so the universe isn't just a place where life happened to show up. It's like it's pushing for life, for consciousness as it computes.
It's definitely mind-blowing, isn't it? And it totally changes how we see ourselves and our place in the universe.
This is all incredible. But before we get too lost in the implications, let's come back down to Earth for a minute. You mentioned experiments. What would count as success? What are they actually looking for?
Depends on the field. In those quantum physics experiments, if they can show that messing with information flow actually changes how quantum stuff happens, that would be huge. Like, statistically significant changes.
So, proving that information is just as fundamental as energy and matter.
You got it. And for the neuroscience stuff, if they find consistent brain patterns that match up with the labels we give things, even if the actual thing is the same, that would be a big deal.
It would be like proving our brains really are making their own little realities.
Exactly. And in those AI experiments, if they manage to get actual intelligence emerging from algorithms based on MQIP, that would be a game changer. It would mean we're starting to understand how consciousness actually works. And maybe, just maybe, we could even make truly conscious machines.
Wow, the possibilities are pretty insane. So we've got experiments at the quantum level, the human brain level, and even AI, all trying to show that reality is this self-defining information system.
It's a wild time to be alive. And the best part, these experiments aren't happening in isolation. Scientists from different fields are starting to talk to each other, share what they're finding. They're realizing they're all working on different parts of the same puzzle.
It's like a scientific team-up, all working together to understand this new view of reality.
Exactly. And I think it's just a matter of time before we start seeing some really big breakthroughs.
Okay, this is blowing my mind wide open. But I have to ask, what about the people who aren't convinced? Are there scientists pushing back against MQIP?
Of course. Any big new theory, especially one as out there as MQIP, is going to have its critics. Some say it's too much speculation, not enough hard evidence to back it up.
So they think it's more philosophy than science.
That's one argument. Others say MQIP is too focused on humans. Like, it's taking human qualities like consciousness and intention and projecting them onto the whole universe. Like, we're assuming the universe thinks like we do, just on a much grander scale.
I get that. Like, if all you have is a hammer, everything looks like a nail. Maybe our only model for intelligence is our own brains, and we're missing something totally different.
It's a valid point, and it shows how important it is to test things rigorously, to be open to other ideas. MQIP might be revolutionary, but it still needs to prove itself.
So it's a journey, and we're still figuring things out, huh?
Exactly, and that's what makes it so exciting. So much to explore, so many mysteries to uncover. Who knows what we'll find as we keep digging deeper into this MQIP thing.
All right, welcome back to the deep dive. We're wrapping up our exploration of MQIP, but I have a feeling this is going to stick with us for a while.
Yeah, it definitely makes you rethink everything. Our place in the universe, all of that.
Before we took a break, we were talking about some of the pushback against MQIP, right?
Right. Some scientists are, they're not buying all of it, especially the more radical stuff, saying it's too speculative, not enough evidence.
Yeah, I get that. It is a big jump, going from seeing information processing in brains to saying the whole universe works the same way.
It's definitely bold, no doubt about that. But I think that's part of what makes it so exciting, you know? It pushes us to think bigger, ask those really big questions.
So it's not just about tweaking our science. It's about questioning, like, the nature of reality itself.
Exactly. MQIP is saying, hey, open your mind. Consider possibilities that would have sounded crazy just a few years ago.
One thing that really struck me about MQIP is how it it bridges science and spirituality. We were talking about ancient ideas like the Vedanta and the Panchakosha.
It's a wild convergence, right? For centuries, spiritual traditions have been talking about this interconnectedness, consciousness being fundamental. And now, with MQIP, we're starting to see those same ideas popping up in science.
It's like science is finally catching up to ancient wisdom, or maybe rediscovering it.
I like that. It reminds us that we don't know everything. There's still so much out there to discover.
Okay, but let's talk about the implications. If MQIP is right, and the universe really is this self-defining information system, what does that mean for us? What does it mean for the meaning of life, even?
That's the million-dollar question, isn't it? And MQIP, doesn't give us a simple answer, but it does offer a new way of looking at things, a new perspective.
Okay, what kind of perspective?
Well, for one thing, it means we aren't just along for the ride. We're actually shaping reality, even at the smallest level. It's not just that we're in the universe is in us, too. And we're all kind of creating it together.
So our choices, our actions, our thoughts, they all matter, not just for us, but for the whole universe.
That's what it looks like. And that's a lot of responsibility. But it's also empowering, right? We're not just cogs in some machine. We're creators.
That's where MQIP starts to connect with those spiritual ideas about living in harmony with the universe.
Totally. If we're shaping reality with our minds, then we got to be careful, right? Align ourselves with how the universe works.
So it's not just about personal growth, it's about cosmic growth too.
Exactly. It's about understanding that we're part of something bigger, something ancient. Our little journeys are all part of this giant cosmic story.
Wow, that's pretty profound. But if the universe is evolving, getting more complex, more conscious, like some MQIP folks say, where's it all going? What's the end game?
I don't know if we can know that. It's beyond us, really, but it's fun to think about. Some people think the universe might become this giant supercomputer, processing information faster and bigger than we can imagine. Others say consciousness itself might become dominant as things get more complex.
Like the universe is waking up.
I like that. It's a possibility that MQIP, well, it makes it real. It makes us see the universe as more than just stuff. It's dynamic, it's evolving. Maybe it's even heading towards some greater level of consciousness.
What an incredible journey this has been. We've explored some seriously mind-bending ideas, and I think this is just the beginning of the MQIP conversation.
It definitely is. MQIP is still new, but it has the potential to completely change how we see the universe and ourselves. It's a call to explore, to ask questions, to imagine, to embrace the mystery.
And that's what the deep dive is all about. Thanks for joining us on this exploration of MQIP, and keep those deep dives going. Until next time, folks.
And so we arrive at the JPEG version of the end. If you're still with us, listener, congratulations. You've officially made it through a deep dive that was, let's be honest, a bit like trying to download the universe on dial-up. It's a lot to take in. We threw around terms like categories, functors, quotient spaces, and enough math to make your brain feel like it's running at 10% capacity. But beneath the complexity, there's this incredibly compelling idea that the universe isn't just stuff. It's a system constantly striving for efficiency, for elegant compression, for truth. If you're feeling a little dizzy, a little disoriented, that's okay. That's kind of the point. MQIP isn't about easy answers. It's about expanding the questions. It's about pushing the boundaries of how we think about reality and our place within it. So, if your brain feels like it's been compressed into a JPEG itself, don't worry. That just means you've been paying attention. And that, in the uncomputably complex universe we inhabit, is a pretty amazing feat in itself. Thank you for joining us on this deep dive into Reality.jpg. Keep questioning, keep exploring, and remember, even in the most compressed version of reality, there's always a spark of uncomputability.